Hi guys, in this video I'm going to be solving the inference in action challenge and talking more in depth about type inference in TypeScript. So to solve this challenge is actually pretty straightforward. This challenge is really just demonstrating what type inference is, and so actually the code is valid. If we run the code, we will see that it passes the tests. And so this challenge is really trying to demonstrate the point of type inference. And so what is that? Let's go ahead and dive into it. So I've taken this code and I've jumped over here to the Pairwise sandbox so we can just look at this in isolation. So these variables, there's 4 variables here, and they are all initialized to be some value. And TypeScript is able to infer the type of these variables from the declaration. So if we hover over the variable names, we will see that they have some associated information with them, namely the actual value. But so basically TypeScript is inferring these to be of specific types based on how they are defined. And you'll notice that we don't have to necessarily say that const b is a Boolean type if we're going to initialize it to be true. So for instance, if I had some kind of function here, like const function which expects a Boolean argument, and we can just say arg is a Boolean type, and let's just return that same argument. If I then come down here and I try to pass in b, or if I try to pass in bar to this function, you will see that there's no issues. We can do either of those things. And then actually, if I said, let's just do this. Let's say let result, and then result equals like that. And let's just do it with a let result 1 const result 2. If we do this and we hover over result, we will see that it's also a Boolean type. So how is that? Well, TypeScript can infer that this function returns a Boolean value because it knows the type of arg here is Boolean, and we are returning arg. So it can understand that this is an arg type because it's typed to be a Boolean, and that we're returning it. So even though we haven't typed a return value for the function, TypeScript is able to infer that it returns a Boolean. And so when we return from this function here on lines 14 and 15, TypeScript can infer that these results 1 and 2 are also of a Boolean type. Now, if I was to come down here and say const baz is actually, we can just use our baz here. Let's say we have const result 3 and we try to pass in baz to this function. You'll see we get a type error now. And so the type error says argument of type number is not assignable to parameter of type Boolean. And it's then saying const baz is 100. So TypeScript has inferred that baz is of type number because it's declared to be 100. And we cannot pass in a number type to this function as an argument where the argument is typed to be a Boolean. So this should all be fairly straightforward if you are somewhat competent in how TypeScript works. But the cool thing here is that a lot of this type information is inferred by the TypeScript compiler as it walks through and analyzes the code. And we don't have to explicitly declare type annotations everywhere. And that's really helpful because sometimes we have either simple types, excuse me, like this, or even more complex types and data structures. And sometimes it's just like not always that easy, or you just don't have the time to go through and explicitly type annotate every single thing you're working with. And so it's really useful in some cases for TypeScript to be able to infer the types of data that you're working with without you having to explicitly type them. So let's look into this a little bit more, and I'm just gonna delete the code we have there. And let's say we have a list of items, and let's just put these 4 variables in our list. Now, and let's just log out our list over here. So here's our list, and we put these 4 different things in it. And if I hover over the list, you can see that we have this type annotation that's inferred, which is a number, Boolean, null, or undefined. So this is a union type using that bar or pipe character. And so this list is inferred to be an array of either numbers, Booleans, nulls, or undefineds. So that's pretty cool that TypeScript can even infer a more complex type like this. Now, what if, let's say this wasn't the case, and let's say that TypeScript couldn't do this, and this would just end up with an any type, and we had to explicitly define a type for this. So let's go ahead and do that. We can say type list item. It's going to be, it can either be a Boolean, and so we're creating a union type here, a Boolean, a number, a null, or undefined. So this is our union type to represent what can be in the list. And so the list itself is going to be an array of list items. And then we can say our list is of type list. So this effectively does the same thing. The main difference is that we have to explicitly write these types out. And this, like many things in programming, has a few different trade-offs associated with it. So the first is that obviously we have to go through and actually write this out. It was a lot easier and much faster in the first case for TypeScript to just infer the type of data in this list, and we don't have to write all these things out. And we also have to figure out a name for these things. Like, should it be called list item? Should it be called like list entry, list element? What about the list itself? So you have to name these things, which is notoriously hard to do. But at the same time, you have a very explicit type definition here. And in some cases, if this data is supposed to represent some specific thing or have some specific meaning attached to it, it can actually be helpful or useful to give it an explicit name, because that's going to be helpful for you and other programmers in the future who encounter this code. So it kind of goes both ways. You have some advantages and some disadvantages, and sometimes you just have to provide explicit type annotations. In addition, maybe this is a list that is used as like a very important data structure in your program. And let's say there's a lot of different code that uses this. In that case, you might have like different functions and different code here and there, which is all looking at these different list items. And in that scenario, it could be really helpful to have an explicit type for those things so that wherever you're using these list items, you explicitly know what the type definition is for the data that you're working with. At the same time, as I mentioned before, sometimes you just don't have time to do this, and it can be very convenient and helpful for TypeScript to infer the type of a list or type of really any of the data that you're working with simply by using its type inference. All right, so let me illustrate one more pretty cool thing here. And let's just say we have some other type, like special value, and this is going to be an enum. And this can be like, let's just put some placeholder data in here like this. So let's just say we have some kind of enum which represents a special value, and let's put that in our list as well. So we've added that special value enum to our list, and as you might expect, it is now included in our inferred type definition. And we could of course go back and write an explicit type definition which includes our special value enum, but for now we're just going to infer that type by declaring the list and using the type inference. So now if I have some more code, actually let's actually give this a variant of the special value, and now you'll see that instead of it being a type of special value, it is actually a special value enum variant. Okay, let's go through and let's do an if statement here. Let's say if, actually let's do this. Let's say const x of list. So we want to iterate through our list and do some logic for each value in the list. We want to say if type of x is equal to Boolean, then we'll do some, let's just log out what this is. Let's just say found a Boolean x. And then let's say else if type of x is equal to number, we will say found a number x. Else if type of, and bear with me, you'll see where this is going pretty soon, and it's going to be kind of cool. So found a null value, and else if x is equal to undefined, found an undefined value. And in these cases of null and undefined, we can just do a triple equals to assert that the item is in fact null or undefined, because if you have a single undefined value, it's equal to any and all other undefined values, and the same goes for null. Whereas with numbers and booleans and strings, not all of them are equivalent, so you need to compare the actual type of. Anyway, so then we have one final case here at the bottom, and down here let's just say const y equals x, and then let's just say console.log y. So let me just run the code, and you'll see it prints out all these things. Now, the point I want to make here is, what if we come down here and we hover over y? What kind of type is y? Well, y is a special value type. So TypeScript can actually figure out, using this if statement here, this series of if-else statements, that by the time we get to this final else block, because we've essentially matched against all of the other types that could exist within this list, by the time we reach this else block, the only type left for x to be is this special value type. So that's pretty cool, because now we know in this final else block, we know exactly what kind of data we're dealing with. And we also know that it's not possible that there's other data in here that we haven't handled. So there's a lot of different sort of directions you could take this observation from here, but for the purpose of this video, I just wanted to present this as an illustration of how type inference works and how powerful it is. We didn't have to provide any additional explicit type information for this code, and TypeScript is still able to understand in a lot of detail what the types of the data are that we're working with. All right, so that's going to pretty much wrap it up for this video. And yeah, this was mainly supposed to be an introduction to some of the basic features of TypeScript, and specifically how type inference works in the language and how it can be a pretty powerful tool to aid your programming in TypeScript. If you like this video, please like it and subscribe to the channel if this is interesting to you and if you want to see more videos like this in the future. And of course, if you want to actually write some code like this yourself, feel free to head over to Pairwise, which is right here, app.pairwise.tech, where we have a few hundred different challenges, just like this type inference one, all designed to help you learn to program. All right, with that, I'm going to wrap it up, and we will see you in the next video.